system. This is part picking robot. This is the similar example that I had drawn previously. This particular robot. So robotic car assembly line you must have seen. बड़ा arm रहता है, robotic arm रहता है, and it just picks up certain particular part and it turns it to some other conveyor belt where some other major part is being built. So it just picks this part and keeps it over here to maybe create a axle wheel connection. Maybe it is a robot which is not just part picking, but it is actually welding a particular door, welding a particular hood of a car, something like that. So there are a lot of part picking robots, actually autonomous part picking robots working in this particular car manufacturing unit. So if you visit or if you see some car manufacturing unit video or a picture, you'll find a lot of robotic arms doing all this work. Now we might think that okay, if it is a robotic arm, there'll be some human being who will be handling through the command line what this particular arm should do, and there obviously should be such a availability of such a person for monitoring whether the things are happening correctly or not. But if I'm having an autonomous robotic arm which is capable of taking its own decisions based on what is coming through the conveyor belt, okay, and some temporal differentiation, what kind of events will occur. Okay, actuators in this case will be the arms and hand, the joints of arms and hands. Okay, so that those will be the actuators. Sensors will be camera, the joint angle sensors, कितने डिग्री में मेरा एंगल टर्न हुआ है. ये तो सिंपल पार्ट पिकिंग का एग्जांपल है. So I need to pick a part from here and keep it here, right? So initially it will be this side, that will be 0 degree, and then I need to turn it to this side. So इतना टर्न करने के लिए कितना डिग्री एंगल होना चाहिए, and all those things. So these are nothing but my sensors that will tell me that. Okay, so environment will be the conveyor belt with parts and bins. So एक part उठा के एक जगह से दूसरी जगह रखना है. So parts जो है वो एक conveyor belt पे continuously flow होते रहेंगे. जैसे ही मुझे part दिखा, so I would have some sort of way to identify that there is a part. Using cameras I can do that. Then the arm will go extend over there. The angles will be adjusted. The fingertips, or as they are called as jaws, will be actually forwarded. The part will be picked up and it will be placed in the bin where it has to be put inside. Okay, so ये part को bin में डालने का काम हो गया. यही काम अलग तरीके से आप define कर सकते हो for any assembly line per se for doing different activities. पेन का ढक्कन एक जगह पे मैन्युफैक्चर हो रहा है, पेन का पीछे का पार्ट एक जगह पे मैन्युफैक्चर हो गया. You want to actually have them both connected together to give it a shape of a pen or and whatnot. So there could be lot of use cases can be thought of for this part picking robot problem. Okay, there can be many such systems that you can think of. Some of them we have talked about right now. Now we go about understanding the details about the task environments. So there are various types of environment that an agent can work in. Now these are few different categorizations of agent task environment. So in the book, if you read, people say that environment types are this or task environment types are these. So what are these? These are some categorization of the agent task environment. कौन से task environment में agent काम कर रहा है, इसका categorization है ये. ये कैटेगराइजेशन सिंगल कैरेक्टर पे बेस्ड नहीं है या सिंगल प्रॉपर्टी पे बेस्ड नहीं है. अलग अलग प्रॉपर्टीज लेके आप एक एनवायरनमेंट को कैटेगराइज करते हो. दैट इज यू एट्रीब्यूट अ पर्टिकुलर प्रॉपर्टी एंड सी वेयर योर एनवायरनमेंट फिट्स इनटू दैट. what I mean by that is we check the observability of the agent in a particular environment. If the agent can observe the entire system or the entire environment and it can accurately model the environment type, okay, or environment state I should say, then that environment is referred to as fully observable or accessible environment. Then there is another type which is reverse to this, which is called as partially observable. So please do not use this word. They have actually written this word here, but please do not use this word inaccessible. Partially observable doesn't always mean inaccessible. Inaccessible. Accessible is correct. Fully observable है यानी मैं पूरा का पूरा environment state को देख सकता हूँ, समझ सकता हूँ, and I can model it. For instance, if I'm a chess playing robot, I can know the entire system. If I'm a part picking robot, I can know the entire system. But if I am the character Dave in the Dave video game, I'm not going to see the entire environment in my first level. As I progress, I will see different levels in the game. So initially, I'll be only looking at the things that are visible to me in the same snapshot that I can see. Okay, for instance, if I am talking about an agent that is playing Age of Empire, and you just start the game, or maybe Need for Speed, and you start a particular trail, and in that trail you will be only looking at some forward steps. You can only see up to say 20 meters, 30 meters for that particular track, and you can't see the entire track initially. As you start navigating in Age of Empire in the map of the world, you will start exploring different places, different resources, and you start collecting them, or you do whatever you want to do. I hope some of you might be buffs in video games and other things. So these tools, the video games like Dev, the Prince of Persia, or something like Age of Empires, something like the uh, Need for Speed, these kind of examples actually are a good task representation for some real world task. So for instance, एज ऑफ एम्पायर एक रियल वर्ल्ड टास्क का एक स्टेप डाउन वर्जन हो सकता है जहां पे एक वन पर्सन इज ट्राइंग टू explore a particular map. Initially, he does not have any knowledge of the map, and he now starts to explore it. How he'll explore and how he'll know the details about different places, different features of that map, how he'll make use of it in order to build his empire. That is what you do in Age of Empire, I guess, strategy planning game, as they refer to it as. Then games like your Need for speed and other things can be somewhat good for understanding how good a autonomous driver would perform on some kind of a circuit. If I have an autonomous driver application installed and I want to actually test pilot it or test run it, okay, so it can be a good simulation world resemblance to any real world problem. And there exactly we can understand few of these kind of environments in which these agents, like a car running on a circuit in NFS, or a game character like Dave, or game character like Age of Empires, uh, what do you call it as the king of that particular empire who starts the game, that particular person, these characters are nothing but our agents, and the environments around them, either they are fully observable like in chess, or they are not fully observable in all other examples that I discussed. So partially observability का मतलब क्या है? इसका मतलब ये है कि आप पूरी की पूरी तरह एनवायरनमेंट का स्टेट को एजेंट के दिमाग के अंदर रिप्रेजेंट नहीं कर सकते. यू कैनॉट जज द स्टेट ऑफ द एनवायरनमेंट accurately. That is what partially observable would imply. So partially observable environment would imply the sensor जो है एजेंट के ऊपर, वो सेंसर थोड़ा बहुत ही जान पा रहे हैं about the environment. Okay, and when actually I have fully observable environment, then I mean that the sensors are giving me enough percepts so that at a time I can model the entire environment. That is what is the difference between fully observable and partially observable environment. What can cause an environment to be partially observable? A, it can be by nature partially observable. Okay, we as a human being, if you are actually traveling to a mountain top from the base of the mountain, it is a partially observable environment, because I can see the top, but I cannot see the path that takes me to the top, right? It has to be navigated by me. That is essentially the characteristic of the environment itself to be partially observable, because the agent's sensors, in this case our eyes, are not capable of understanding all the great details about the path to be taken to reach the top. Okay, Next thing that makes a particular thing partially observable could be the sensors being noisy. Okay, when it comes to certain appliances like a robotic car or other things, if my camera has lost one channel, okay, of processing, or my camera hoist is not moving correctly and it has to move in 80 degrees angle, with an 80 degrees angle, but there is some physical damage to it so that it can move only in 60 degrees. So दोनों साइड से 10-10 डिग्री का जो angle है, that I'm missing, so I might not be able to capture any vehicle coming within that angle because my camera is not now able to move. So there can be these kind of noisy inputs which may actually give you a partially observability temporarily or permanently. Okay, there can be inaccuracy in the measurement. So if I have a say sonar sensors or some kind of a sensors which work on some physical property of the matter which is used for the sensing purpose, and that physical property has due to maybe wear and tear or something else has become inaccurate, so that can be a thing. Missing sensor, so I'm expecting a sensor to be there but the sensor actually is not working at all or it's not present at all, then that can be the case, or that can be the reason of being partiality. Okay, so partially observable environment poses different kind of questions about agent being able to model the environment accurately. So state of the environment using a partially observable agent would be some kind of approximation to actual state. क्योंकि अगर स्टेट रिप्रेजेंट करने के लिए मुझे 4 अगर सेंसर चाहिए और मेरे पास 3 ही सेंसर है, तो वो एक सेंसर का वैल्यू मेरे पास नहीं है, तो होगा क्या, एजेंट विल हैव 3 accurate values using which he will say that this property has this value, this second property has this value, third property has this value. But since I don't know the fourth property, the device now can be any one of these belief states. ओके, बिलीफ स्टेट में होगा क्या, ने मैं कह सकता हूं कि ये 3 प्रॉपर्टी के कारण ये 3 मुझे पता है प्रॉपर्टी, लेकिन चौथा प्रॉपर्टी है जिसमें शायद 3 अलग अलग वैल्यू होते थे. अगर वो प्रॉपर्टी के 3 अलग अलग वैल्यू है तो आई कैन एक्चुअली थिंक ऑफ दैट actually the environment could be in state S1, S2 or S3 depending on what is that fourth value. The example that I'm telling you right now is something of this sort. Say suppose to define state of environment, say Si, I require 3 properties P1, P2, P3, and instead of having these 3 properties, due to partial observability, I only am able to quantify or understand the 2 properties, that is P1 and P2. Then the third property P3 is a guess that I can make. Okay, suppose the domain of this property 3 has 2 possible alternative values, 1 and 0. Okay, just the possibility I'm saying. Then I may think of that such system, since I know what are the values of P1 and P2 for accurate with accuracy. Okay, there is no issue for this value P1 and P2, but P3 can be equal to 0. This will give me, sorry, P3 is equal to 0 will give me one state of affairs of the system, and this could be the other state of affairs of the system. So these two I may think of as my belief states. I can believe that the system could be in state P1, P2, 0, or system could be in state P1, P2, 1. Okay, so that is what happens when your environment is either partially available or fully observable. If it is fully observable, I have all the ingredients there for representing the state of environment. If it is partially observable and I don't have certain information, I have to understand what could be different states the environment could be in. Now the choices I make when I know the environment completely and choices I make when I don't know certain details about environment, they will be definitely different. Okay, so we'll continue.